Alright guys, welcome to Piecewise functions. So this is just going to be a little bit of an introduction to piecewise functions, specifically being able to graph them and being able to find their domain and range. We're actually not going to write equations for piecewise functions. That's later on when you guys see pre-cal. So when you talk about piecewise functions, what they are is exactly in the name, piecewise, pieces of different functions. So when we look at it, when functions are defined by more than one equation, we have a piecewise function. Different pieces, collections of different equations come together to make our function. Okay, and more specifically here, we're going to restrict the domain. So here's an example of a piecewise function. We're going to say this function here, f of x, is defined by these three pieces. Now here is where we write our equations. On the right side is where you're going to write your domain restrictions. And so we're actually going to come back to this one later on. But notice the three pieces that make up our function is the linear equation negative x plus 1, the point x equals 1 and the output is 2, so the point 1, 2, and the equation, the function y equals x squared, where x is greater than or equal to 1. So these three pieces are our piecewise function. Okay, so be careful, the domains here are restricted by the piecewise function. So these domains, okay, restrict where and how we're going to graph these pieces here. Okay, this is really important, piecewise functions, when we get into learning about continuity and functions being continuous and discontinuous at particular points when we get into calculus. Okay, so in example 1, we're going to go ahead and graph two linear equations. Here, graph the following function below. State the domain and the range. So here's our function. F of x is equivalent to 2x plus 3 if x is less than or equal to 3, and 3 minus x if x is greater than 3. So what they're saying here is that if you're picking a value that is 3 or less, we're going to be using this function. If you pick a value that's greater than 3, you would use this function to plot. So let's look at how I graph this. Here I created two tables. One of them is in red, and that's x and 2x plus 3, the output. Okay, so notice when I graph this function, my x's now are not all real numbers because of this linear function. We have to restrict them to using x values that are less than or equal to 3. So when I make the table, I've used values that are less than or equal to 3 for x. 3, 2, 1, and 0. I just did 4 points so I can get a general idea of the line. And I plug 3, 2, 1, and 0 all into that first equation. You don't plug them into both. You plug them where your x's are defined. They're only going to be defined, the values that are less than or equal to 3 in this first function. Notice how here 2 is not in this domain because 2 is not greater than 3, so 2 would not work here. So be very careful on which functions you choose when you're graphing. So I get the outputs of 9, 7, 5, and 0 respectively, so I went ahead and plotted these. So here's 0, 0, okay, 1, 5, okay, 2, 7, and 3, 9 is up here, okay. I'm sorry, I went by 2s here, so there's 1, 5. 2, 7, and 3, 9. Okay, and I drew a line. From that point, and that last spot at 3 is filled in because I can include 3 here. It's filled in, and I draw my line downward because these are all the values that are less than or equal to 3. Now, the second equation I did in blue, x and 3 minus x. And notice that my x values all have to be greater than 3. So I put 3, 4, 5, and 6. And notice how I put 3 in red. I'm saying x is greater than 3, okay, but I have to have somewhere to start. So I'm actually going to put 3 into my function. 3 minus 3 is 0. And so there's going to be an open circle at 3, 0. And that tells me I can use all the values up until 3, but I cannot include 3. So there's an open circle. Okay? Many people make the mistake of saying, oh, well, I can't use 3, so they go to 4. But you could use 3.5, 3.25, because 3.25 is greater than 3. So that's why we still plug in 3 into our function, but instead of a closed circle, we have an open circle because we cannot include that value. I plug in 4, 5, and 6, and I get negative 1, negative 2, and negative 3 respectively, and I plot those points. and I graph my function. Okay, these are both linear, and so are these graphs. The next thing is domain and range. You can see that I'm covered from 3 to negative infinity and 3 to positive infinity. So the domain actually here is all real numbers, and you can see that if you look at the graph left to right, every value is defined. The range is actually going to be all real numbers as well, because you start, sorry, it's not going to be all real numbers. I lied. It's going to be less than, we're going to include 9 here and go to negative infinity, because we don't go any higher than that. It's less than or equal to 3. So the range is 9 to a negative infinity. Now we're going to graph a second piecewise function. We're going to also state the domain and range. Here's my function, f of x equals 3 if x is less than 2, and 2x minus 1 if x is greater than or equal to 2. Okay, so let's plot the red line first. If x is less than 2, the output will always be 3. This is actually going to be a horizontal line. It's not a point this time because it's not x equals. It's x is less than 2, then the output is always 3. Less than 2, so I'm going to start at 2 with an open circle, and anything less than 2 is going to be a value of 3, so it's a horizontal line going to the left. Now, I'm going to plot 2x minus 1 now for all values that are x greater than or equal to 2. So I've made my table here, 2, 3, 4, 5. Okay, I started at 2, and I plug all those x values in, and I get 3, 5, 7, and 9 respectively. And so I went ahead and plotted that here in blue. Notice how at 2 I get 3. And so in the first function I was at, if x is less than 2 and I'm at 3, so there's open circle. So I went ahead and put an x over that to signify that's another equation. I did a different color. You could have filled that circle in as well. The domain of this function, you can see that from 2 to negative infinity we're covered. And we can include 2 now because of this second function, and 2 to infinity we're covered. So this domain is all real numbers. The range, notice how the range, there's nothing below positive 3. So notice how this is where we start the range, and it goes all the way to infinity. So the range would be 3 to infinity, and you can include 3 there. Our last example goes back to the first board where I introduced what a piecewise function would look like. So that's again, the function is defined as follows. So let's find f sub 0, f of 1, and f of 2. Now notice here, my x value is 0, my x value is 1, and my x value is 2. You need to see which piece to evaluate the x for. You can't just plug them in all 3 or just pick one. If x is 0, let's look at our domain restrictions. Well, I can't plug 0 in here because the domain restriction is that x has to be greater than 1. I can't use 2 because x has to be equal to 1 in order to have a 2 for an output. But I notice that 0 is less than 1 and is greater than or equal to negative 3, so I found my match. So the x is 0. The equation is given by f of x equals negative x plus 1, that first equation. So we have f of 0 is equal to the opposite of 0 plus 1, which is just 1. So I plug 0 into that first equation. When we look at f of 1, okay, we know that x is 1. Okay, so if we look at that middle piece of the graph, when x was 1, our output is always 2. So the answer to this one, when x is 2, when x is 1, or f of 1, the answer is 2. Lastly, f of 2, we know when x equals 2, the equation is f of x equals x squared. So we plug 2 into that, and we get 4. I'm tired today, sorry. Jeez. Part B, determine the domain. So I just rewrote the function here. I guess I should put f of x here for you to see. Okay, there's our function. Determine the domain. Well, let's look. We know the smallest number for x is going to be negative 3. X is greater than or equal to negative 3, but less than 1. We have 1 covered. It wasn't in the domain here, but now 1's covered by the second piece. and we know that all the values past 1 are covered by this last piece. So when you look at the domain, it's not all real numbers because we don't go past -3 for x. Okay, so the domain is defined by x such that x is greater than or equal to -3. Interval notation, we have -3 to infinity. Inequality form is here. So the domain there is x is greater than or equal to -3 for the domain. The last piece we're going to graph. So I rewrote the function again with the restrictions. The easiest one to graph is the middle point. If x equals 1, then y is 2. So you go 1 and 2, and there's our green dot. Okay? If we plot x squared, x has to be greater than 1. So I'm going to plug in 1, and I get 1. The axis is by 2, the y-axis is by 2, so I get 1, 1, and then I plugged in 2, and I got 4, 3, and I got 9, and I connected the points. Notice on the red graph there is nothing past 1 being plotted. 0's not in there because x has to be greater than 1. So the idea is set up a t-chart and start with what this restriction is and go from there and plug the values in for your part of your function and get the outputs. The last one is a linear equation, -x plus 1, and I'm picking between 1 and -3. So those are my x's between -1 and 3, and I plug each of those integers into my equation. If I plug 0 in, notice I get 1. If I plug 1 in, I get 0. I plug -1 in, I get 2, and if I plug -3 in, I get 4. And I draw my line, or my segment. Notice how there's no arrow going this way or this way, because it's a piece. It's only from -3 to 1. And you can see for the domain here from -3 over, okay? And the range, if you wanted to know the range, would be from 0 to infinity, okay? So that's piecewise functions, graphing them and finding the domain and range. So if you have any questions or comments, you can email me at nicholas.bennett@dc.gov or type your comments below. And we'll see you next time.